DNS is an extremely important service for IT because although users and applications will typically use a name to connect to a computer itself needs to know the IP address of the computer it needs to connect to. Not surprisingly, therefore, once you've built your first DNS server, Bind does give you the option to add redundancy by creating secondary servers. But how do you create a secondary server in a Linux distro like Ubuntu, for example? Well, if that's something you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, before you can create a secondary DNS server, you do need to have a primary server already available that is fully functional and doing your DNS resolution. If you're not already familiar with how to do that, then I do have another video already released that covers how to actually create a DNS server using Ubuntu. Now, although the goal is to create a secondary DNS server, the first thing I want to do is to make sure that the software on the primary DNS server is already up to date. That way, when I install Bind onto my secondary server, both servers will be running the same version. So I'm just going to paste a line in. So we're going to do sudo apt update, and then we're going to be doing sudo apt upgrade. And I'll put in the -y as a parameter so that it'll actually answer any prompt should one come back to actually ask if we want to update any packages. So I'm just going to hit return, get this to update itself, and then we'll pick up from there. Now, the next thing to do is to update the configuration of our primary DNS server. This is to give the actual secondary server permission to access and download the zone files that will be used for DNS resolution. So when it comes to Ubuntu, I need to go to /etc/bind, have a look there, and the file that I'm interested in is this one here, name.conf.local. So we're going to edit that file. And what I need to do here is to add in some additional lines, and that's going to be to both actual zones, because we're interested in being able to do resolution for the forward lookup zone as well as the reverse lookup zone. So these two lines I'm going to be pasting in are these ones here. So I'm just going to tab those in. I need to do that again for both. So basically what the first line does is to actually allow zone transfers. That's what the terminology is when we're actually copying the actual zone files from the primary to the secondary. So we're basically giving permission for this specific IP address in this case. That's the IP address I'll be using for my secondary server. We're giving permission for this specific server to be able to do these zone transfers. But I also want an additional line, which is to notify the secondary server when a change takes place. So whether we're doing an actual static DNS change ourselves, or in my particular case, I'm using dynamic DNS. When that takes place, when there's some change takes place within the zone file due to an update, the secondary server needs to know so that it can then download the latest version of the file. So I've done that for both zones. I'm only running two, but you'd have to do this for every zone that this particular server that you've got is responsible for. So now I've added those two lines, I'm going to save the changes. And then what I need to do is actually restart the service for that change to take effect. So we're restarting the Bind 9 service. And then we're going to check to make sure that that's actually worked. It hasn't generated any errors. So yeah, it's come back and it's active and running. So now it's time to create our secondary DNS server. So I've created another computer which is running the same version of Ubuntu that our primary DNS server is running. And I've also made sure that the software on this is also up to date. So now when we install the Bind 9 service, I know that it'll be the same version that we're running on our primary server. So I'm just going to copy and paste the line in, and then we'll get that installed. So now that the Bind service is installed, the next thing to do is to configure it. So I need to switch over to my actual Bind folder. So that's /nt/bind. We have a look in there. What I need to do is edit that name.conf.local file. So sudo nano And then what I'm going to do is paste in the configuration that's relevant to me, or more specifically my network. And it's pretty much very much the same as what's been done with the primary server. I mean, if I actually go over to the primary, you'll see we've got our zone templab.lan. That's what my domain name is. The type for this is master. The type for this is secondary. So what sets them apart is that the master server has an actual writable copy of the actual files. This is the only server where changes can be done. The idea is the secondary gets a read-only copy. It makes the whole process of replication much simpler. I'm not going to try, setting up multiple masters. I'm going to keep things simple. So this one, the primary server keeps a writable copy. If I need to make any changes manually, if dynamic DNS here needs to make any changes, it'll get done on this server. Then the secondary server just stays up to date. I've got the redundancy in that if the primary actually were to get updated, rebooted, for whatever reason it's no longer available, at least I've still got DNS itself working. I'll lose the option to be able to make changes, but in this day and age where we're into virtual machines, it'll be really quick to restore that server anyway, so I don't really foresee any problems doing it this way. We don't have to do things like allow transfer or notify here, but we do need to tell this specific DNS server where to find the master server, where to actually go and get these updates from. So I'm pointing it to the IP address of the primary. And because I've got a forward zone as well as an actual reverse zone, I have to define both. So I'm going to save that configuration file. Next thing to do is to actually reboot this actual service, because I need the changes to take effect. And then I'm just going to double check that it's actually working and not reporting any issues. Okay, that's good. Now I'm storing the actual zone files in the /var/lib folder, so I'm going to have a look in there. If we do ls-l/var/lib/bind, you can see I've actually got two files that have been copied over as part of that actual zone transfer, and it even mentions the transfers in the actual feedback here of the status. So it's actually gone out and it's actually copied these two files from the actual server here. So as far as I can see, it's working fine, but obviously we want to test this out. Now this computer that I'm using is actually pointing to the primary DNS server for DNS resolution, but I can actually use the NS lookup command, for instance, so that I can actually get it to do some DNS resolution using my secondary server without actually affecting the configuration on this computer. So what I want to do, for example, because all we've set up is an internal DNS server. So all this secondary server is doing at this stage is internal DNS resolution. So I'm actually going to ask it, what's the IP address for my DHCP server, for example. So we've got NS lookup and then the fully qualified domain name of the computer. And then I'm going to give it the IP address of the actual secondary server. So I'll just double check, yep, that's right IP. So it's come back and it's told me that's the IP address. Now I can also do a reverse lookup just to double check. So NS lookup, we ask it for 172.16.17.10. And again, pointed to the secondary server. It's come back and told me that's the IP address belonging to my actual primary DNS server, NS1. So as far as I can see, it's capable of doing the actual zone transfers, and it can also do actual DNS resolution, or at least internal DNS resolution. Now the next thing to do is to restrict access to this DNS service, but while I'm actually at that, I'm actually going to enable DNS forwarding for this server, because I've actually got my primary server set up so that it can resolve internal as well as external computer names. In which case, because we're dealing with redundancy here, I may as well get the secondary server to be able to do both functions as well. So if the primary goes out of service, maybe due to maintenance for instance, computers will still be able to get access to host names for internal computers as well as for those external computers. So we're in this /etc/bind folder, so we'll have a look in this folder here. because I need to edit this named.conf.options file. So sudo nano, and then I'm actually going to just remove the existing example that they've got there, and I'm going to paste in what is almost identical to what I've got on the primary server. So basically up at the top, we're defining what computers, subnets can get access to the services we're going to be using. We're going to be doing actual recursion as part of the DNS lookup process. That way it just saves time basically for computers. The actual DNS server does all of the work so that it actually returns the IP address of the actual name that the computer was asking for. Without that, what the actual computer would get was the IP address of an actual DNS server for it to go off and interrogate. So this speeds the process up, especially, as I'll point out now, is the fact that we're restricting access to DNS queries, but we're also setting up the ability to get access to cached queries. So when a computer asks to resolve a fully qualified domain name, what the actual DNS server does is it goes off and gets that actual IP address, but it also caches it. So it means the next time a computer comes around and asks for that same fully qualified domain name to be resolved, this DNS server already knows it, and as long as the computer's got access to the cache, well, it speeds the process up. And then the next line we've got here is just to restrict what actual computers have got access to, the ability to do this recursion. The next block I've got down here is to list the forwarders, because as I say, we're setting this up as a DNS forwarder. And I want this server to go off and talk to another DNS server that's actually resolving the public IPs. Now, when I set these up, Bind 9 wasn't yet capable of doing the more security features for DNS, such as DOT and DOH. It can now. That's something I need to add in. But at the moment, that's all being done by another DNS server. So that's why this server points to another DNS server and not directly to, for example, these Cloudflare servers that I've got here. But the other server does use those, because then that restricts access and blocks out the potential for getting access to known malware sites at least. Again, because at the time there wasn't really much purpose in going down the security path with Bind, that's why DNSSEC validation is still disabled. But then we just got our other two lines to define what actual IP addresses the DNS service listens on. And that's why basically this is the only difference between those two servers that I've got, because the IP address here is different on this server to what it is on the other. But I'm going to save those changes there. And then what we'll do is we'll restart the actual Bind service for these changes to take effect. And then I'll just go and check that the service is working. So this server should now be capable of both internal as well as external DNS resolution. Now, one last thing that I want to do on this secondary DNS server is to actually point it back to itself for the DNS service. Because when I set this computer up, I installed Ubuntu and I pointed it to the primary DNS server so that it could get updates from the internet. Now, obviously, if the primary server goes out of commission, maybe due to maintenance, the secondary server is currently relying on that primary server. So what we're going to do is we're going to change to the netplan folder. So that's /etc/netplan. Let's have a look there. And there's a YAML file that I need to edit. So sudo nano, I'll just tab that out rather than typing it all. I need to change the entry here for the name server. So I want to point it back to itself. So it'll use its own DNS service. So we'll point it to the loopback address. I'll just save that. Then we'll do sudo netplan apply. Now it is coming back with a warning saying that the gateway 4 entry has now been deprecated. And now it uses a default root entry instead, but the video is more about being able to set up a secondary DNS server, not really anything to do with IP addressing, netplan, and so on. But it's just something to bear in mind. It does work, but at some point it might actually get removed. So it's something you need to be aware of. Well, the secondary server should now be operational, but all of the computers that are out there will be using the primary DNS server. So what we need to do is to actually introduce them to that secondary server. And what you can actually do is to configure a computer to use more than one DNS server. That allows you to add the extra redundancy in, but also give you a bit of load balancing as well, potentially. Now, I've got a Windows computer here, and currently it's only pointing to the primary DNS server. So as you can see, it's been able to connect to Microsoft's website, for instance. If I try to ping, say, my DHCP server, it should be able to resolve that IP address. Yep, so it's been able to go to the primary server, and it's given it the the actual IP address belonging to that DHCP server. But what I actually want to do now is just test out the functionality of that secondary server, just to make sure everything's working. So I'm going to open up Control Panel. That's one way to get in there. I'm going to go to Network and Internet, View Network Status and Tasks. I'm sure there's a much quicker way of doing it, but ultimately I want to get to this section here, change the adapter settings. I'm going to right click on that network card that I've got, select Properties, scroll down to my TCP/IP settings, click Properties, and instead of pointing to .10, which is the primary DNS server, I'm going to point this one to .11 instead. So it should now be using the secondary server to get access to things. So go back to our command prompt. I'll actually try and get it to resolve the name for the primary server itself. So it's able to get the secondary server to resolve the IP address of the primary server. So at least I know it's doing internal resolution and it's allowing access, because we did add restrictions in. And what I'm actually going to do is point this to, let's try to go to cisco.com, for example. So if it goes and it's doing DNS resolution for that www.cisco.com, so it's working both internally and externally. Now, when it comes to actually doing the configuration for these actual devices here, I mean, it varies depending on the actual operating system, but typically you'll be putting in both servers in here. So if we go back to the settings, if we put 172.16.17.10, it's a bit deceptive, I must admit. It varies depending on the operating system, and it seems to vary even within a vendor. Each operating system that come out, they might make a slight change to the behavior. Because I know what used to happen was that if you defined two DNS servers, what used to happen was the client would just send a request out to both computers, and it would wait to see who would come back with the quickest response, and then it would just use that IP address. But I've noticed, at least Microsoft I've noticed anyway, can actually cache which server it uses. So at the moment, it's set to prefer .11 and use .10 as an alternate, if you will. What might actually happen is that it might actually at some point decide, well, I'm getting a quick response from .10, and it might start using .10 going forward. Then after a while, it has problems getting access to .10 if it goes out of service, in which case it flips over to .11. So it's very haphazard. It changes, I must admit. As I say, it was a lot easier where they used to just send out a flood of requests, and it used to just ask more than one DNS server at the same time. It was just a case of who's going to give me the quickest response. But yeah, I can't guarantee its behavior. If I click on Advanced, go to DNS, you can see you can actually add multiple DNS servers here if you want to. So that's something you might want to think about. So the order, what you put here, I don't think it really matters to a great degree, especially if it's going to change over time with something like Windows. But at the moment, I'm just going to leave this pointing to the secondary and leave the alternate as the primary, just for the sake that the primary would expect it to be a bit more busier, especially because I've got it set up to do dynamic DNS updates. But it's such a small network, I wouldn't really expect that much of a performance hit anyway. But I'll click OK. And it just means that this particular computer is now set up so it should be able to function no matter which of the actual DNS servers is operational. Might be a slight delay and sometimes in the response. Again, it really depends on how the operating system is going to behave. So what you can do is just try somewhere else. So say like fred.com, for example. That always seems to vary. Yeah, so now it's a luxury jewelry site. Okay, fair enough. I think that name seems to go change over the years, but it is still working. but at least what I know is that both of my DNS servers are working. What I'm going to do is I'm going to go back to the other server. And what I'm actually going to do is I'm actually going to disable one of the services. So if we go back to this one, is currently pointing to the secondary. That's its preference. So if I do a sudo system ctl stop bind 9. So that is now actually stopped. We go back to our Windows computer. I'll try Yahoo instead, for example. So this way I'll test. It's got a choice of 2 DNS servers. So now it's gone over and it's talking to the primary by the looks of it, because we disabled the secondary. So what I'll do is I'll bring this one back again. We'll stop the one on the primary instead. Go back to our Windows computer. Just out of curiosity, well, try and Google, why not? So it's connecting to Google by the looks of it. So just to double check, status on the primary is down, and the status on the secondary is up. So because we've got it configured to use both DNS servers, we've now got our DNS redundancy, and that should work for internal as well as external. So I'll just double check that. Ask it for NS2, for example. So yeah, so it's working both internally and externally, regardless of which DNS server is going to respond. Now the last thing that I want to do is just to check that the secondary server is keeping up to date with the primary server. In other words, if a change takes place on that primary server, is the secondary being notified, and is it then actually downloading the latest copy? So here we are on our secondary, and there's its timestamps. So if we go for the primary, because I'm using dynamic DNS, I'm just going to have to pause things a bit, otherwise dynamic DNS might get in the way. So we'll do sudo rndc freeze. We're going to then edit our actual forward lookup zone, so db.templab.lan. I'll just move the serial number along, so I'll set that to 156, and call this, put in a new entry of my server. It's 72.16.19.50. We'll save that. Things back the way they were so that dynamic DNS will work. So if we then go back over to our secondary server, so that's moved along, so it looks as though it's been updated. The only trouble is I can't really get much out of this actual file. Whereas the actual one on the masters makes sense, this one's just gobbledygook. If we do, even if I go in with nano, it's just doesn't make a lot of sense in there. Yeah, it's not easy to tell. But what I'm going to do is I'm going to go over to my Windows computer. So this one, we're going to point it back just to use the secondary, because the whole part of the test is the secondary now up to date? It looked as though it actually downloaded the latest version of the file, but we'll double check from here. So at the moment, it's only going to be pointing to the secondary DNS server. So click OK, click close. I'll just go back again because I've already forgot what that. So it's my server, right? Okay. I already forgot what I put in there. So it's my server. So if we do ping my server.templab.lan. So there. So by the looks of it, it is actually working. So whenever a change does take place on the primary, it's notifying the secondary, and then the secondary is downloading the latest version. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, as that'll help get the video out to more people who might find it useful as well. If you've got any comments or suggestions, please post those in the comments section below. And if you're new to the channel and you'd like to see more content like this, then yes, do subscribe. Just remember to set the bell icon to actually send you notifications when new content gets released, although I also post to Twitter as well as Facebook. If you'd like to help the channel and support it, you can actually make contributions through PayPal and Buy Me a Coffee. I've also got links to Patreon, and there's also the join membership option for YouTube itself. Patreon and YouTube members do have the option to actually benefit from early access as well. But above all, many thanks for watching this video. I'll see you in the next one.